Hello everyone. This video will be on the 2.1 section of the IB/AA curriculum. It is going to be a review for a lot of you from the grade 10 math, so if you need to review some concepts, please take some time to do that on your own. Please pause the video now for a second to look at the concepts, contents, and formulae for this section. One sentence that summarizes the section is that there are different forms of equations for a straight line. The immediate question is why? Each form has a benefit of its own, so I will explain them later one by one. First, a line can be defined using two properties, gradient and a point. Gradient, aka slope, decides how steep a line is. Imagine you're standing on the line and looking towards the right or positive x direction. You can do this by placing your left ear on the line. If you're seeing the uphill, the line has a positive gradient. If you're seeing the downhill, the line has a negative gradient. If you're seeing a flat prairie, the line has zero gradients. If you're seeing a wall, well, that's something different. A point determines where the line is. Two lines with the same gradient could be apart from each other. Where the line is can be found by using any point on the line. Graphically, this means that a point on the coordinate plane is on the line. The gradient can be found using the gradient formula. This formula uses 2 points, so find the points that are as close to the cleaned end as possible. For example, I'm going to use the gradient formula given by the IB formula booklet. And let's find some clean points on this line. Maybe this point is clean. I'm going to call that point number 1, where my x value is -3 and the y value is -4. Let's use another point here. I'm going to call that point number 2, and the x value is 3 and the y value is 0. Now, m equals y2, so it's 0, minus y1, which is -4. x2, or the x value of the second point, is +3, minus x value of the first point, which is -3. A special point that may be useful for any of you will be the intercepts. The y-intercept is a point where the line meets the y-axis. The x-intercept is a point where the line meets the x-axis. Algebraically, the y-intercept is the y value when the x value is 0, and the x-intercept is the x value when the y value is 0. I can see that my second point here was actually an x-intercept. My y-intercept would be here, where the x value is 0 and the y value is -2. Let's talk about the forms of the equations of the lines now, using the concepts we have built. The gradient intercept form is the form that is most commonly used for some obvious reasons. There are two pieces of information needed: the gradient and the y-intercept, as the name implies. Already you can see how simple that is compared to others. The m stands for the gradient and c stands for the y-intercept. You can see that the c is the y-intercept, since when x is 0, y equals c. This form is useful for two big reasons. First, it is easy to graph. Simply locate the y-intercept and draw a line with the correct slope. Second, the upcoming sections in quadratic relations will use the upgraded version of the gradient intercept form, so you should get used to the shape here. GI form, y equals, and the m value, we found it, 2/3, x, and then the y-intercept, which is -2. Done. The point gradient form is an alternate version of the gradient intercept form, where x1 and y1 represent the x and y coordinates of any given point on the line. You may call this a generalized version of the gradient intercept form. This form is useful for graphing, again, because you're not limited to using the y-intercept, unlike the GI form. However, in my opinion, I don't really see the point of this form. PG form y equals y minus, and let's use the first point actually. My first point, the y value is negative 4, equals my m over 3 x value was negative 3. Done. Lastly, the general form, aka the standard form, is in my opinion the most distinct one. There are three pieces of information, A, B, and D. A and B together represent the gradient by the equation negative A over B equals m. D represents the point. However, I don't really like this form because they're not so straightforward as the two other forms. One aspect that this form is specifically useful is when we solve the system of equations, where we solve for the variables using more than one equation. Other than that, I suggest that you stick with the gradient intercept form. Let's take the GI form and then we're going to put everything on the left hand side. So at negative minus 2 over 3x and plus 2 on the left hand side, or on both sides. You get negative I'm going to multiply both sides by negative 3, so we get rid of the fractions. Done. One skill that you need to practice is moving back and forth from one form to another. One tip that I have is when you transition between point gradient form and general form, go through the gradient intercept form. It will make your life a lot easier. The last part of this video will be the types of questions that may appear in the test. You may be given 2 or more lines and asked to identify the relationship between those lines. First, you may want to identify the gradient of each line and label them such as M1 or M2. Let's look at 2 lines here, where the first line, I'm going to call that number 1, and the second line, the green one, I'll call it 2. M1, we already found it from the last question. It was 2 over 3. M2, let's see. It's negative 1. When they're equal, like I mentioned earlier, they're parallel to each other. When their product is negative 1, or in other words, when one is a negative reciprocal of the other, it means that they are perpendicular to each other. It means that the 2 lines intersect each other at a right angle. If you're interested in finding the point of intersection of 2 lines, you may want to use the system of equations from this general form. Or simply put the right-hand side of the GI form to either side of the equation and solve for x. Again, a sad reality that the GI form is taking over the spots of the general form. Let's see. So, like last time, the first line is 2 over 3x minus 2. And the second line, y equals negative x, and the y-intercept is positive 3. Positive 3. What I'm going to do is I'm going to put these 2 sides equal. Why? Because y value should be equal for our intersection. Let's put the like terms together. After we find the x value, we can substitute the x with any of the equations. So we can see that at the point of intersection, the x value is 3, the y value is 0. I hope you enjoyed this video, and try some questions in this section to really master the skills that we have learned. Anyways, I will see you in the next video. Best wishes!